see different shapes of color on a daily basis. But have you ever really thought how your vision works? Let's start with the basics. In order to see, your eye must focus light on the retina, special cells on the back of your eye. Convert the light into electrical impulses and send those impulses to your brain to be interpreted. It is an amazing and complex process, but you do it constantly without even trying. When light runs off an object and reaches the eye, it must be bent so that its rays arrive at the retina in focus. 4 different surfaces bend the light as it enters the eye: the cornea, the layer that covers the front of your eye, the aqueous humor. This watery fluid fills the front of the eyeball between the cornea and the lens, which helps the cornea to focus light onto the retina, the vitreous humor. This is a thicker jelly-like liquid which fills the larger part of the eyeball behind the lens and keeps it in shape. When all 4 of these bends the light approximately, you see a focused image of the object. The eye can focus objects at different distance because the ciliary muscles push and pull to make the lens change shape. When you look at an object that is far away, the ciliary muscles relax and the lens has a flattened shape. When you look at an object that is close by, the ciliary muscles are contracted and the lens is thickened. In addition to focusing the light, your eye can control how much light gets in. The color part of your eye, called the iris, controls the size of the pupil, the opening that lets light through. In dim light, the iris will cause your pupil to expand, allowing as much light as possible into your eye. In bright light, the iris causes the pupil to contract so that less light can enter. What happens when the focus light reaches your retina? It triggers a complex chemical reaction in the light-sensitive rod and cone cells. Rod contains a chemical called rhodopsin, or visual purple, and cones contain chemicals called color pigments. These chemicals undergo a transformation that results in electrical impulses being sent to the brain through the optic nerve. When the electrical impulses arrive in the visual cortex of the brain analyzes the color and light information from the rods and cones and interprets them as light. The brain flips the image. The light was projected on your retina upside down and fills in for the blind spot if it's necessary.